Hi all, welcome to Soumya's Tech Talks. Today we will have tutorial on C programming functions part 2. So before going through this tutorial, please go through the part 1 so that it will be understand easily. Today we will discuss on below topics. So the advantages of functions and its limitations and macros, how to write functions using macros, inline functions, and also we will discuss naked functions, which is called you write some function in assembly code and recursive functions, and we will also discuss stack overflow. Let's continue. So when it comes to advantages, you already know the code is reusable. Like if you write a function like CRC calculations or encryption functions, anything you can write, arithmetic functions, any algorithm, that functions can be reused anywhere in your code, or it can be reused by others also. And modularity, as instead of writing the code, lengthy code, you can break it into different pieces, functions, and give meaningful names, so that it will be a modular, like you are dividing into multiple modules. And ease of maintenance and easy debugging. So how it works, when you break your functions, code into functions, whenever bug comes or enhancement comes, you can only change or debug the specific function instead of going through all the code. And also you can develop the uh, projects very faster, because you can delegate the functions, you can break the system into different functions, and multiple engineers can work on it parallelly, so that the development will be very faster. And it improves the readability, because you break the code into meaningful functions, and then you give nice comments, so that people will understand what the code is going to do. Let's start. First we will start with the limitations. So the main limitation is the stack operation. Like in earlier tutorial we discussed what happens when the function executes. It involves lot of stack operations, prologue, epilogue, that adds some delay. In modern computer systems like your laptop servers or modern phones, it's okay. But if you see the real time, like time critical embedded systems like sensors, medical devices, defense systems, so where the time is very critical, it will be critical with respect of microseconds and milliseconds. In that case, this will add some overhead, so we should be very careful while writing uh, interrupt handlers or ISRs. Okay, so let's start with macros. So C macros, like instead of writing a function, you can also write a macro using hash define. See here I can write a macro for swap. It is same as how you do swapping of two numbers using a swap function, but here instead of function we write a macro. So macro normally start with hash define and name, and you can have arguments. So whatever arguments passed, a b, whatever you passed, so here in place of a, that will be replaced. So see here I declared one more variable based on type. Means here type you can pass anything, int, float, double, any type, it will be, type will be replaced. If you pass int, int will be replaced here. Double will be replaced. Rest you know already, the swapping function. So we have this character because, so when you writing a multi-line macros, you have to write this backward slash. It indicates that your code continues in the next line. So this is the syntax. You can write a very larger function also. You can write like this and put at the end of each line you put this one. And how to call this, you can call like this: swap, I pass x, y, and int as a type. So that what the, how this works, whenever when your code is building, the preprocessor will replace this call with this all code, like this all instructions will be placed here. See, one instruction call to macro will replace all the code like this. Finally your code will be replaced like this: int temp equals to x. So as per your macro it will be replaced, so that there will be no stack operations here. So whenever you call this, it will be directly insert that instructions. So there is no stack and everything. So it is a continuous flow of instructions. So this is the macros. But macros are not easy. It looks simple, but it has a lot of limitations. Advantages is it is direct code replacement, no stack operations involved, and it is very faster. But the disadvantages is, so the code will be replaced, like when you call a macro, so as per your macro definition it will be replaced, but it never check for compile errors or runtime errors. Whatever it is there, it will be there. So you will either you will get a compile error, sometimes you don't get a compile error, but runtime you will get some strange errors, your code will be malfunctioning. So we should be careful when we are using the macros. And we can also check the compiled output, the preprocessor output, and see what it is generated. And it is difficulty in when you want to write multi-line macros, it is very difficulty and not readable, and also you cannot debug. It is very difficult to debug also, because you cannot put breakpoints and everything, very very difficult. So we should use it only required, like don't always use macros, it is not preferable. So only if required use it, but always try to use single line macros. So don't use multi line, avoid it. And also it is better to avoid the macros completely. And let's see another part of functions which is almost similar to macros, but they are not macros, like they are inline functions. So what is inline function? You have a keyword inline in front of your function. So like how macro works, so whenever you call anything, the same code whatever inside this inline will be, it will be replaced. Okay, and the compiler will replace this code, and here also there is no stack operations involved. So you can write instead of macros you can write inline functions, but here also there is some limitations. So we will see what is that. So one is it is direct code replacement, no stack operations, and very easy compared to macros, and it won't give you any compiler runtime errors. But the disadvantage is you can write only small functions, like if your function is having very limited line, like less than 3 or 4 lines, you can use inline. But if it is very larger, the compiler will ignore your inline keyword and it treats as normal function only. Normal function means it will have the stack operations and everything as usual. So that is the limitations of inline functions, but it is very useful if you write a very short functions which have very 4 lines, 3 lines, less than 5 lines. Okay, so now we will go to another section which is naked function. Naked means it is not supported by standard C, but if you are writing any embedded or bare metal programming with ARM architecture or any other architectures, you can write a C function which have the assembly code. So here I have given an example, but it is a very complex topic. But you just remember that whenever you use for normal desktop server whatever applications, it is not required. But when you are doing the core embedded systems projects or RTOS projects, so this is very useful. You can write assembly code. The main advantage is, like macros and inline, it don't have prologue epilogue sequences, so you can write a naked function like this and you can just jump to that, you can call this directly. Okay, very useful if you are writing a interrupt service routines, like if you have a interrupt call which should be executed very quickly without having the stack operations and everything. So these naked functions are very useful. And you also can access using assembly language, you can access the system registers, like you can directly access the system registers and change their values, and you can have a full control on the system. But it's sometimes not preferable because it's also having some security concerns, like some malicious code accidentally change some system registers or something, it is a problem. But most of the time we, in bare metal programming and RTOS programming, we use it. It requires the instruction set. You should understand what instruction set supported by your system. Like if you are working on ARM architecture or Intel architecture, anything, you should know the instruction set, assembly instruction set, you should know, then only you can write this. So we will go to next one, which is the recursive functions. So recursive functions are regular functions only, but what happens, uh, function will call itself. Like how it works, the function will execute, it will check a condition, the condition fails, it will return, or if it is true, it will execute function code and then again call the same function, recursive call with the same function. But different you can pass different arguments or same arguments, but it happens until the condition is false, it will keep on executing, and once the condition fails at some stage, it will return. So we will see more, like here one example of recursive function where I print numbers from 1 to 100 without using any loop. So how we print numbers, for I equals to 0, I less than n, something we will write, or while loop or something we can write. But here you can see I didn't use any loop, I just use a recursive function. Like if n is greater than, then I will return. So I will stop the recursive calls. If not, I will print the current value and I will call same function with next parameter. Let's say first it will be called with 1, 1 will be printed, same function will be called with 2, 3 until 100. So here I am calling with 1. So first 1 will be printed and it will call with 2 like this until if n value is greater than 100, it will stop the recursive call. So like this we can use recursive calls to do the repetitive task. So how it works? So first recursive call will be happen sequentially. Once last one is done, every function will be returned. Like it is a reverse order, like how you call, the last one will be return first and next one, like this, it is a reverse order. And also every time when you call a function recursively, it creates a stack frame for that iteration, for that recursive call. Even though it is same function, whenever you call recursively, for each recursive call a stack frame will be created. It will have its all the variables, arguments passed, local variables, all the copy. Each recursive call have its own copy. Okay. So once the function returns, last one returns, the last one stack frame will be removed and stack will be cleared, and next one, like this it happens. Okay, this is how recursive functions works, and we will see the advantages and disadvantages. Advantage is the previous, like when you call a recursive function, the previous state, like previously with what arguments it is called, what is the state of local variables, everything will be available in stack, you can use it. So it is widely used in algorithms like data structures and algorithms. It will be used which needs a previous state. Like if some algorithm wants what is my current state and what is my previous state, or what is the value of a variable previously and current value. So in such cases this will be used. And disadvantage, it involves heavy stack operations. Like whenever you call a stack recursive function, one stack frame will be created. So it involves lot of stack and consumes a lot of stack space, memory space, and sometimes it will also explode the stack and makes the stack overflow. So this is the recursive functions. And we will see the stack overflow. So stack overflow is generally an error when it happens. It happens when your allocated stack memory is completely occupied. Like as we know from the previous lectures, the stack grows dynamically till the heap, right? So when the stack is full and hit the heap, end of the heap, then the system throws that the stack is overflow, and it will either kill the process or it will restart the system, or in case of embedded systems it will throw exception, so where the you have to reset the system. So why the reasons for stack overflow is, one is infinite recursive call. Like you have a recursive function which never stops, it keep on calling, and it leads to infinite recursive calls. And also in sometimes your stack memory is very less and you call too many functions, nested function, one function to another function, in that another function, if you key, the stack memory will be explode. And also if you are creating large local variables, like when you are creating arrays or some variables in the inside your function call, inside of function code, which are called local variables, if that local variables need more space, which may also leads to this stack overflow. Okay, today we will end here and we will continue on further lectures. Thanks for watching, and please share with your friends uh, who are eager to learn advanced C programming. Thanks to all. Bye.